Today, I am going to have a discussion on concurrent forces, the conditions to have the equilibrium of the concurrent forces, and Lami's theorem. First of all, we have a concept on concurrent forces. What are concurrent forces? If two or more than two forces are acting at the same point, then these forces will be called concurrent forces. Concurrent forces. If two or more than two forces are acting at the same point, then they are said to be concurrent forces. Okay? For example, we have considered a body of mass m. A body of mass m and number of forces are acting on it. F1, F2, F3, F4. As these forces are acting at the same point, they are said to be concurrent forces. Now you have to discuss about its equilibrium conditions. Concurrent forces in equilibrium. We know a body is said to be in equilibrium if the number of forces acting on it give a resultant equal to 0. First of all, we are starting with two forces. Two forces. A simple example is that a block is lying on the ground. If m be the mass of the body lying on the ground, then it will have simply two forces. One is due to its gravitational pull, that is mg. We must denote it as w vector is equal to mg vector. And we all know that every action will have equal and opposite reaction. So, as the ground is giving an action as the block is giving an action W in the downward direction, it will have a reaction in the upward direction. That is, the ground will give a reaction to the block. Similarly, at 180 degree, named as N vector. We all know N is actually the reaction given by the ground to the block. N is the normal reaction and it is the reaction of W. W is the action. M will be in equilibrium. M will be in equilibrium if the resultant of these forces is 0, and simply the case is like that. W and N, action and reaction, so they will have equal magnitudes, and to show that they are in opposite direction, we must introduce a negative sign. So bring n minus n vector to the left side and it will simply becomes w vector plus n vector is equal to 0. So the block of mass m is in equilibrium as this resultant or sum of the forces acting on it gives 0. Now consider three forces. Consider three forces. let us have a look. Now consider a block of mass m and three forces are acting on it. Consider it to be F2, it to be F1 and it to be F3. They are concurrent forces and they will be in equilibrium if F1 vector plus F2 vector plus F3 vector is equal to 0. Now simplify it. F1 vector and F2 vector will have a resultant. First of all, F3 is acting in this direction, shifted in 180 degree. That is, this is considered to be R vector, which is actually at 180 degree. So R vector is nothing but minus F3 vector. Okay. Now, if we further conclude it to be a case of parallelogram, then R vector is the diagonal of that parallelogram. F1 vector and F3 vector are two vectors and they are adjacent side of a parallelogram. And we all know from parallelogram law that if F1 and F2 are two adjacent sides of a parallelogram, then its diagonal, that is R vector, will represent its resultant. So R vector is nothing but F1 vector plus F2 vector. Now put the value of R vector. F1 vector plus F2 vector is equal to minus F3 vector. So F1 vector plus F2 vector plus F3 vector becomes 0. So for three forces, M will be in equilibrium if the resultant gives 0. Similarly, for n number of forces, F1 vector plus F2 vector plus F3 vector plus Fn vector equal to 0, then M will be in equilibrium. Now, special theorem named as Lami's theorem can be introduced if three forces are in equilibrium. If three concurrent forces in equilibrium, then we will have a theorem known as Lami's theorem. Lami's theorem. If three concurrent forces are in equilibrium, then from Lami's theorem, we can write, consider the angle between F3 and F2 vector is alpha. Consider the angle between F1 and F3 to be beta. Consider the angle between F1 and F2 to be gamma. Then M will be in equilibrium. Lami's theorem will be applicable here. F1 sin alpha, F2, consider the other two forces F1 and F3 and the angle between them, that is beta. F2 by sin beta, and F3, consider the other two forces other than F3, they are F1 and F2 and the angle between F1 and F2 is gamma. So we can write F3 by sin gamma. Okay. What is alpha? What is alpha? Alpha, angle between F2 vector and F3 vector. What is beta? Beta is angle between F1 and F3. And what is gamma? Gamma is angle between F1 and F2. Okay. In the next video, we must discuss the numerical based on this theorem. Thank you.